Today we will cover unit 1, that is solubility of drugs. Now what is solubility? Solubility is defined at a specific temperature, that is maximum amount of solute that can dissolve in a amount of solvent. Means हमारा कितना solute कितने amount of solvent में dissolve करता है, उसका maximum amount, उसको बोलते हैं solubility. In a qualitative way, it can be defined as when solute is to be dissolved in the solvent. Solute can be any solid, liquid, gas, and solvent may be solid, liquid or gas. It form a homogeneous solution of the solute in the solvent. Students, there are various definitions of solubility. According to IUPAC, it is defined as an analytical composition of a saturated solution expressed as a proportion of a designated solute in a designated solvent. It is called as saturated solution. Okay, the solubility depends upon the various factors. It depends upon the solvent, temperature, pressure. The solubility can be expressed in several ways. For example, ppm, that is parts per million according to BP, and in mg per ml, and in moles per liter. Okay, the United States Pharmacopoeia describes the solubility of drugs as parts of solvent required for a part of solute. You will see in table, this is table 1, USP, that is United States Pharmacopoeia, describes the solubility of the drugs as parts of the solvent required for a part of solute. मीन्स कितने solvent के parts required है हमारे कितने part of solute के लिए, उसको हम बोलेंगे solubility according to the USP. This is the table, students. You can see on the left side, on the very left side, you can see various solvents, that is very soluble, freely soluble, soluble, sparingly soluble, slightly soluble, very slightly soluble, practically insoluble. Very soluble solvent, first of all, first one you can see parts of solvent required for one part of solute, that is less than 1. Freely soluble 1 to 10 parts, soluble 10 to 30 parts, sparingly soluble 30 to 100 parts, slightly soluble 100 to 1000 parts, very slightly soluble 100 to 10,000, and practically insoluble, that is parts of solvent is greater than 10,000. And solubility range of very soluble is greater than 1000. For freely soluble, solubility range is 100 to 1000. For soluble solvents, it's 33 to 100. For sparingly soluble, it's 10 to 33. For slightly soluble, solubility range is 1 to 10. For very slightly soluble solvents, solubility range is 0.1 to 1 mg per ml. For practically insoluble solvents, the solubility range is less than 0.1 mg per ml. You have to learn this table. This is according to the USP, that is United States Pharmacopoeia. It describes the solubility of the drugs. Next, students, we will study the determination of solubility, that how the solubility is determined. It's a simple method for the determination of solubility at the laboratory scale. Okay, saturated solution of excess of solid substance with solvent is prepared. Okay, we will prepare the saturated solution of solid substance with the solvent by simply shaking in a vessel which is placed at a constant temperature bath. Okay, then we will filter the solution. Okay, during the filtration, the solid may be deposited on the filter paper, okay, or on the in the stem of the funnel. You have seen the filtration process na? Here the solid may be deposited on the filter paper, or it can be on the stem of the funnel. A known volume of saturated solution is evaporated. Okay, we will evaporate it in the china dish. Okay, then after that we will see the we will weight the residue that is left, and solubility can be calculated. Okay, this is a flow chart of solubility determination which I have explained you. Okay, evaporation of liquid is a highly undesirable operation. This difficulty can be overcome whenever a chemical analysis method is used. So this is the method by which we can determine the solubility. Okay, next are the solubility curves. There are various solubility curves, okay, that are drawn between the solubility and the temperature. This first curve you can see, this is a solubility curve for a saturated solution. Okay, this is the solubility curve of saturated solution. On the one side you can see the solubility, on the x-axis you can see the temperature. This is a graph between the solubility and the temperature for a saturated solution. Okay, any point on this line, red line, it will represent a saturated solution. You can see. Next, this is the solubility curve for an unsaturated solution. On the y-axis solubility is represented and on the x-axis temperature is represented, and this is a red line, solubility curve. Okay, any point below the line represents the unsaturated solution. Okay, the solvent contain less than the maximum amount of solute. So this is a solubility curve for unsaturated solution. You can see in this graph. Next students, this is a solubility curve for super saturated solution. Okay, this is a solubility. On the y-axis same, that is solubility is represented, and on the x-axis temperature is represented. Okay, this is a red line which show the solubility curve for a super saturated solution. Means any point above this red line, it will represent a super saturated solution. In a super saturated solution means the solvent contain more than the maximum amount of solute. So this is a super saturated solution solubility curve. You can see. Next there are various methods of solute solvent interaction. Solute solvent interaction means that what are the interactions between solute and solvent. Students, you have already studied the concept that like dissolves like. ठीक है, means polar dissolve polar, non-polar dissolves non-polar. Okay, the solubility of solute in a solvent depends upon the nature of the solvent. Means जो solute है हमारा, उसकी solubility किसी भी solvent में depend करती है कि वो solvent है उसका nature कैसा है, whether वो polar है या फिर वो non-polar है. The solubility also depends on the chemical, electrical and structural properties that cause mutual interactions between the solute and the solvent. There are various interactions between the solute and the solvent. Okay, the solubility of the drugs is due to the polarity of the solvent. Okay, for example, this is a flow chart which explains the mechanism of solute solvent interaction. That what are the various interactions between the solute and the solvent during the solubility process. You can see in this flow chart, first of all, there is a cleavage of solute intermolecular bonds, क्योंकि जो सॉल्यूट है उसमें भी इंटरमोलिकुलर बॉन्ड्स होंगे. ओके, तो वो इंटरमोलिकुलर बॉन्ड्स पहले ब्रेक होंगे, क्लीव होंगे. ठीक है. सेकेंडली, क्लीवेज ऑफ सॉल्वेंट इंटरमोलिकुलर बॉन्ड्स मीन्स सॉल्वेंट के जो इंटरमोलिकुलर बॉन्ड्स हैं वो भी हमारे क्लीव होंगे. ओके, देन देयर इज अ फॉर्मेशन ऑफ कैविटी फॉर्म होगी हमारी सॉल्वेंट की. ओके, दैट विल एकोमोडेट द सॉल्यूट मॉलिक्यूल. देन द सॉल्यूट मॉलिक्यूल विल मूव इनटू द कैविटी ऑफ द सॉल्वेंट फेस. Okay, then there is a formation of solute solvent intermolecular bonds. You can see in this flow chart. Now next topic is solubility parameters. There are various solubility parameters. Students, in 1936 Joel H. Hildebrand proposed the solubility parameter, that is delta. Delta is the square root of the cohesive energy density. You can see the formula. Delta is equal to delta HV minus RT upon V1. Okay, raised to power half or under root. Here delta H is equal to heat of vaporization, R is the gas constant, T is temperature and V is the molar volume of the liquid at the desired temperature. Okay, this is the equation of the solubility parameter. The value indicate the solvency behavior of the specific solvent. The cohesive energy density is the amount of energy required to completely eliminate the unit volume of neighboring molecules at an infinite separation. This is equal to the heat of vaporization of compound, okay, divided by its molar volume in the condensed phase, means delta H upon V1. You can see. Solubility parameter provides a numerical estimate of the degree of interaction between the materials. Means solubility parameter की importance क्या है? It will explain us the degree of interaction, that what is the degree of interaction between the materials, and its unit of measurements are calories per centimeter cube. Okay, these are the various units. SI units are joule raised to power half, m -3/2 raised to power. ठीक है, it is equivalent to the Pascal raised to power 1/2. Another solubility parameter is Hansen solubility parameter. There are two solubility parameters we are studying here. Second is Hansen solubility parameter. It was developed by Charles M. Hansen. Okay, by his name this parameter is called Hansen solubility parameter. It consists of three parts: a dispersion force component, okay, hydrogen bond component, and a dipole component. Hansen parameter formula you can see. This is the formula of the Hansen solubility parameter. Here delta T square is total Hildebrand parameter, delta D square is dispersion component, delta P square is polar component, delta H square is hydrogen bonding component. Okay, this is the sum of these components. This is the Hansen solubility parameter. Next topic is solvation and association. Students, commonly it is solvation. First of all we will discuss. Solvation is also called as dissolution. Okay, dissolution, it is a process of attracting and associating the molecules of a solvent with the molecules of solute. Means in this figure you can see solute molecules plus solvent molecules. They will form the solution. Means solute will associate or attract with the solvent molecules to form the solution. This process is called as solvation process. Means formation of solution, or it is also called as dissolution. When the solute dissolve in a solvent, then solute gets surrounded by a solvent molecules. This process is called as solvation complex. Means the solvent molecules will surround the solute molecules. Okay, a complex is formed. This is called as solvation complex. Larger the ion, the more solvent molecules can surround it and more they are solvated. Now for solvation to occur, the energy is released to form a crystal lattice, okay, in which they are present. The solvation energy is defined as the amount of energy related with dissolution of a solvent. If it is a positive number, the dissolution process is endothermic, and if it students it is negative, then the dissolution process is exothermic. Okay, next topic is association. Association of ions is the chemical reaction in which the opposite electric charge ions, opposite electric charge ions means positive ions and negative ions, they come together in a solution to form a distinct chemical entity. Association means association of the two oppositely charged ions that come together in the solution and they will form a distinct chemical entity. The extent of the ionic association depends on the dielectric constant of the solvent. That what is the dielectric constant of the solvent? Okay, now the ions of opposite charge are naturally attracted to one another by electrostatic force. Means जब ये oppositely charged ions हमारे solution में आएंगे, ठीक है, तो वो क्या होगा, उन ions का क्या होगा, they are attracted to one another by the electrostatic forces. पॉजिटिव नेगेटिव की तरफ अट्रैक्ट करेंगे और नेगेटिव पॉजिटिव की तरफ अट्रैक्ट करेंगे. देन दिस इज डिस्क्राइब्ड बाय द कूलम्स लॉ. कूलम्स लॉ स्टेट्स दैट F इज इक्वल टू Q1 Q2 अपॉन R स्क्वायर, eta R square. Okay, where F is the force of attraction, Q1 Q2 are the magnitude of electric charges, and this is sign for dielectric constant of the medium, and R is the distance between the ions. The ion association will increase if the magnitude of electrical charge Q1 and Q2 is increased. Okay, the size of ion decreases so that distance R between the cation and anion decreases. Okay, it will depend upon the size. Third is the magnitude of dielectric constant. decreases. Okay, the ionization will increase if the magnitude of dielectric constant will decrease. That's for all for today. Thank you.